Hello everyone. I'm going to go through job number 19. It's in book number 2, the white book. And what job number 19 is set up for is really to pound into your head this formula right here. As a service technician, through the years, we didn't have capacitance checkers on our digital meters or on the meters that we had for many years, so we had to use this formula very regularly to check the microfarad rating or the total capacitance of a capacitor in the circuit. The book states very clearly that it's a common thing for capacitors not simply just to go out, but to lose some of their total capacitance. And a lot of times that can only be checked while it's in the circuit. The majority of our modern meters today check capacitance out of a circuit. But when you put them in a circuit and you put a load on them, their capacitance can change. And so what this board is set up to do is to take each capacitor and put it right across line, parallel to a load. And I've drawn a diagram here showing you what we're doing. We're taking 120 volts, L1 and L2, through a switch and wiring it directly to a capacitor parallel to a light. And we're putting a light parallel to the capacitor to remind us when the capacitor's in the circuit, because we don't want to leave a capacitor in a circuit too long or an electrolytic capacitor can blow up. We talked about that in class. So we have to do this test very quickly, checking volts and amps. I've already drawn this on the board here. I've taken some time and went ahead and checked the voltage, of course, at every capacitor is 122 volts. And now what I'm going to do with the capacitor in the circuit is check the amperage of each one. And what you're going to do in this lab job and turn in is simply use this formula, taking amperage that I'm going to acquire here for you, multiplying it times a constant of 2650. So amperage times 2650 divided by volts will give us the total capacitance. I cannot overemphasize enough how important it is for you to memorize this little formula, taking it out in the field. Amps times 2650 divided by volts equals capacitance. Remember, capacitors are on condenser fan motors, they're on evaporator fan motors, they're on compressors, they're virtually everywhere in our industry, and this is a very common practice for you to need to know what the total capacitance is on a motor, okay, and other loads. So let's go ahead and do one of these. I'm going to do capacitor 1 first. I've put a multiplier loop. This is a 10-rat multiplier loop because some of the total amperage to the capacitors may not be high enough. So when I take this, I'm going to have to divide this number by 10, and I'll, it's just moving a 0, so it'll happen really quickly. But I'm going to go ahead and check the amperage of capacitor number 1. Turn it on. 122 volts, 43.3 amps. I move the decimal. Of course, that is 4.33 amps. Capacitor number 2. $66.7 amps. 6.67 amps. Capacitor number 3. $109 amps. $10.9. Capacitor number 4. $27.8. Okay, now those were start capacitors. These are run capacitors. You can see the symbol is changing. This is a run capacitor. This is a start capacitor symbol.
1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1.
10.4. Seven point one. Three point six. And last, 1.9. Okay, so now that is the job, and the job does also remind you that you need to take a bleed resistor, which is just a 5,000 ohm resistor, and put parallel to these capacitors to discharge any of the stored voltage that they might be holding. I'm going to turn the power off. I'll do that after the video, but you definitely would not want to go across or get your body across a capacitor that you have just charged, because what do capacitors do? They store electricity. So what we're going to do is use these numbers right here. You can see them, and I will add an assignment. You write these down, and I'll add an assignment to the lab, and you can complete using the formula, complete this task and turn it in. Thank you.